Welcome everybody. Nice to see you here for learning. In this video, we are going to talk about subprograms and modularity. Okay, about subprograms we just discussed before. We had introduced this before, and in this video we are going to talk about it in detail and in depth. Okay, why should we use it? What are the good things about it, and how should we use it? Okay, and modularity. Modularity simply it means writing different blocks of code for different things and just then using them. It means dividing your program into many modules, okay, and many parts. So let's dive deep into it. See the first one, a subprogram. What is a subprogram? A subprogram is a self-contained block of code that performs a specific task within a large program. So see, we can have a spaghetti code writing everything in the same file and just in one block. And we can just do the decomposition, create modules, create just different parts, okay? And write each code in its own specific place, okay? So that is modular design. We just simply divide our program into parts and just code for each part separately, okay? So subprograms only need to be written once and can be saved in libraries to be reused as many times as needed. So as you can see, this makes your life a little bit easier and your code more manageable. See, for modularity, we have gotten 5 pillars, okay? We will just discuss about each one of them. The first one is complexity reduction. Writing code for a very big program is kind of difficult and it's complex, but if you just divide that into some smaller sub-problems which are just easier, so you can simply write codes for each part more easily, and kind of the complexity has been reduced. The second pillar of this is reusability. So as we told you, you can just write a subprogram's code once and you can just save it and you can use it as many times anywhere you want, okay? So that is just another good thing. If you use modularity and you use different files for different parts of the program and subprograms inside them, so you can use them as many times as you can. The next one is easier maintenance. So see, subprograms are smaller, they are simpler, so they can be just fixed if there is any error inside them more easily than just think about a very large program with all the code written at one place, okay? So finding the error, then rectifying that will be just a very big headache. But with subprograms and modularity, you're just simply creating smaller programs and they are easier to maintain and debug and solve problems in them. Then the other good thing is team collaboration, okay? If you have divided your program into many smaller projects or just subprograms, simply you can manage your team so each part of your team can work on different parts simultaneously, okay? So that will reduce development time. And logic clarity, okay? Modularity or subprogram replaces blocks of code with a single meaningful subprogram name, making the program's overall logic instantly readable. So you have written your subprogram in another file. In your main program, you will just not write all the program there, simply giving your subprogram a understandable name or identifier. In your main program, you will just simply write that identifier, okay? So that defines what happens here. So that makes it more clear, okay? Simply you will know that, yeah, here something like this happens, okay? How that is done right now, you're not focusing on that, so it just makes your code more clear, okay? So these are 5 pillars of modularity. Then in subprograms, we have gotten 2 types of subprograms: procedures and functions, okay? Procedures may or may not take parameters. Parameter is just simply the inputs. Every function just can take input, it cannot, okay? So procedures may or may not take parameters but do not return any value, okay? They just do not give any value back to the main program. They execute a sequence of commands only. Then functions may or may not take parameters but must return a value, okay? A value must be just given back to the main program. They compute and send data back to the main program. So the golden rule here is functions must return a value and procedures do not. See, parameters and generalization. You have just coded something and you have introduced some parameters. What are parameters? For a subprogram, you will just simply define some variables that in function calls, and when you want to use those subprograms, you will just simply give different values, and this subprogram will store those values inside this variables. Okay, so parameters are variables passed into a subprogram to supply it with the specific data it needs to run. Then see, raw subprogram with parameters that later you can just give different values to these parameters will just make an infinite generalization. Simply it means this code can be used for different inputs and without just needing to rewrite that. Okay, so by passing different parameters, a subprogram can carry out the same task for different input values without needing to rewrite the code. The next concept that we are going to study about is variable scope. Variable scope, simply it means in which parts of your code is a variable accessible. You can just access it, you can change its data, or you can read its data. Okay, so in scope we have gotten two types of scope: global scope and local scope. Okay, global scope, simply see, as we can see here in our main program, we just create a variable here. Then this variable can be just used everywhere. For example, think about this: there is a phone here, and from anywhere you can just simply call that phone. So that is a global scope. Okay, so global variables are created in the main program, then after that in your subprograms you can just use that. Okay, so created in the main program, access can be accessed from any part of the program, and scope are in scope throughout the entire program. So that is global variable. Okay, then local variable is just created inside a subprogram or inside a block of code, then it can be accessed only inside that. Okay, and why should we use this? It is safer. Okay, so creation declared or created inside a function or blocked code, indented or brackets, access only accessible there. It means inside the function or inside the block of code. Okay, only in scope with the function in which they are declared. Why do we use it? Safer. It prevents accidental overrides from other parts of the program and makes debugging localized and manageable. So see, Edexcel procedure syntax and function syntax. Okay, see, writing a procedure now in pseudocode, we will just simply write the procedure, give it a name, then the parameters inside brackets. Okay, begin procedure and end procedure. Inside that you will just write a set of instructions that it needs to do. The same thing we have gotten for functions, only instead of procedure we can just write their functions, then name, then parameters, begin function, end function, and inside this you will write the instructions that computer needs to do. The difference is, okay, in functions you will have this return statement, return then a value. Okay, so that return, whatever you write in front of it, will be just it will just give that back to the main program. So notice the formal begin and end structure is specific to Pearson Edexcel standards. Okay, so now that is important for your exams, specifically paper 1. Okay, to execute this, the main program uses calls like add marks, then 1 number, 2 number. Okay, so function calls or subprogram calls are simply name of the subprogram, then inside the bracket for those parameters you will just give some arguments or some values. In flowcharts, how you just simply create and call subprogram. Creating a flowchart, simply you will write a new flowchart, and inside start of that, okay, instead of start you will write the name of the subprogram and the parameters. Then in the end, if it is just kind of function, then yeah, you will write there your return this thing. So that is just end, start and end, and calling that is just with this shape. Okay, so this is the symbol for that, a rectangle with 2 lines around it. Say, and calling it simple here, authenticate user, maybe that is just another subprogram, and here simply I just call it authenticate user, and it does not take any input. If it takes any input, you can just simply write it here. Okay, then after that, yeah, you can perform your own thing. So a subprogram condenses an entire complex algorithm into a single clean flowchart step, hiding the underlying complexity from the main flowchart. So see, now this authenticate user subprogram might be very lengthy, okay? But in our main program, simply we are using, yeah, authenticate user. So if that is correct, then after that do this. So it makes your logic more understandable. Some exam tips, okay? So the return rule checklist, always, if it is function, be careful about the return statement. You must have it. If you do not have it, then it is procedure, okay? Then meaningful identifiers, always, just again we are telling you, try to use meaningful identifier, never use single letters like X or T or things like that, okay? And also for identifiers with more than one word, try to use just any of the camel case or snake case, okay? So that makes it easier to understand for the Edexcel committee to check, and for yourself to not make mistakes. And the global warning, okay? Avoid overusing global variables. Try to just use local variables wherever it is possible, okay? Because that demonstrates robust and secure programming. Practice zone, some questions are here, okay? Define a local variable and state one benefit over a global variable. So created inside a block code or function, only in scope there, benefit prevents accidental manipulation by the main program. Second question, okay, identify the scope of the variable bonus, okay? So we have gotten a bonus that is created inside the procedure. So that is local scope, only accessible within the update procedure. Then construct a function in Edexcel pseudocode named calc area that takes radius as a parameter and returns the area of a circle. So that is function calc area, the parameter for that is radius, and begin function, end function. So set area to pi value multiplied by radius to the power of 2. Okay, so that will be calculated, stored inside area, and after that return area. So this is a function. So that's all about subprograms and modular programming or modularity. Okay, wish you all the best. Do not forget to like and subscribe our channel. See you next time.